Alright guys, so here's another example. We have a circle K shown. The arc measure NPL is twice the size of the arc measure NL. So NPL is this one. NPL is this side. This arc, major arc, is twice the size of the minor arc NL, which is this one. Alright, so we don't know what they are, so we're going to call this X, and we're going to call this, if this is X, this would be twice the size, so it's going to be 2X. So let's write it down. The arc measure NL, if NL is X, then the arc measure NPL will then be 2X, because that's twice of X. Now we know that a full turn for a circle is 360. So our next equation, our equation would then be X plus 2X equals to 360. If we go around the circle, it's going to be 360 degrees, and each arc will add up to 360. So we have 3x combining like terms would then be 360. If we divide this sides and both sides by 3, we will get x equals to 120. So x is 120, this is 120. If x is 120, 2i's x would be 240. So this distance is 240. Now, we have the major arc 240, minor arc is 120. What do we need to find? We need to find NML. We need to find NML. We need to find this angle right here. Now, in order to do this, this is an inscribed angle, so we need to look for the corresponding central angle. This inscribed angle is between the endpoints N and L. So we have to look at the central angle with the same endpoints. So the central angle with the same endpoints would then be this angle right here, which is 240 because of the arc measure. Now, if that's 240, if this is 240, we know that the equation says inscribed angle will then be 1/2 of the central angle or 1/2 of this major arc, which is major arc NPL. And we know that NPL is 240, so it's going to be 240. So it's 1/2 of 240, which is 120. So the inscribed angle NM, and the inscribed angle NML is 240. 120, I'm sorry.